morning, everybody. It's great to be back and to talk about the future. Yesterday, you may remember, we talked about today. Now we're going to talk a little more about the future. But in doing that, I wanted to take a couple of takeaways from the earlier session that we had. The first and most, I thought, prominent takeaway is that obviously simplification is very complex, and we need to keep on culling and keep on refining. But the question then becomes almost: do we cut too deep? Do we not cut deeply enough? And in doing that, do we put under threat the resilience of our entire system? Which probably leads me to my opening, one sentence only question, which I like to start with, and I'm starting as ever at the far side. Paul, what does resilience mean?
Good morning, everybody. Paul Bosman, Eurocontrol Network Manager.
Oh, sorry, thank you. Yes, Paul Bosman. Do you know who they are? Their names are up there. Is any man or woman on this panel need an introduction?
No. Okay, so Network Manager, I guess you've heard about us. We're working on a mandate from the European Commission, doing basically network management, flow management. In short, if ever your slot gets refused, it's us. Yep. We do one or two other things.
You mean here the en route slot, not the terrestrial slot?
Absolutely. Yeah. And my particular role in Eurocontrol in the Network Manager is that indeed of head of infrastructure.
This is a very long single sentence. What does resilience mean?
Making sure, in my particular case, it means making sure that we don't lose capacity that we so desperately need because of hiccups in the infrastructure setup.
Okay, and I will give you a two-minute promotion on the Network Manager here, if you like. Making sure we don't lose the capacity that we need.
Yeah.
I presume as the Network Manager you take a network-wide view of that.
Yes.
Right. Do we have the flexibility, though, to shift available capacity to a place where the capacity is under serious threat?
I think we are demonstrating this on a daily basis. Whenever there is a shortage in one country or another, whether it's because of a strike, whether it's because of meteo events, whether it's because of geopolitical situations, we are shifting them from one country to another, one sector to another, etc.
Okay, that's the perfect segue to talk about France. Not so much geopolitical events, but industrial events. Catherine, what's your definition of resilience?
First, I'm Catherine Rouflenado. I'm from the French...
As you can see from the names up on the screen.
Air navigation service provider. And here, because now I'm the head of Pyrenees ATC Center, and I think I'm the one from the field. So I can just explain you how every day we try to improve the resilience and how we try to make the system working, even if we have failure. If we have probably we will be back on that. We have malicious people trying to do things, but I think our resilience is based on the 3 layers we have. We have this strategic ATM is based on 3 layers. First, the strategic one. So from the beginning, we designed the airspace, we designed our systems, and we have this capacity and the relationship with you to be sure that we are going to be able to manage the traffic. This is done at strategic level, so this is done before any flight. Then we have the tactical level. Tactical is real time. So even if everything seems to be smooth at the beginning, some days things happen, strike, weather, we don't know. And we have this real-time organization with the air traffic controllers so that we are able to manage conflicts, for example, failures, and this is the everyday work we are doing. And if this failed, we have what we call, emergency abnormal situation, and for that we have tools we have safety nets, but this is not the everyday work.
I love that you put strikes in your strikes in your stuff that we normally have to work around all the time. It's an everyday thing, as opposed to a major crisis. You also mentioned, Catherine, very interestingly, malicious players. Dan, Copenhagen's such a wonderful haven of peace. You don't have malicious players getting to Copenhagen Airport, do you?
Yeah, we do sometimes. I would say, yeah. We definitely see a rise in that due to the geopolitical situation. So for me, resilience is all about being able to maintaining business continuity when something happens that we're not planning that's happening.
Right.
But other than that, we need to learn from these events and being able to adjust and adapt into what's happening in our surroundings.
Right.
Because the players are changing all the time, and we need to be aware of that and change our strategic methods of dealing with it, because otherwise we'll be stuck.
Well, indeed, and again, we are going to come back to malicious players, I suspect. Hete, from an EASA perspective, I hope you also noticed, incidentally, ladies and gentlemen, that I am an equal opportunity offender when it comes to mispronouncing people's names, so I apologise for that.
You're doing well.
Oh, so far so good. That's very kind of you to say. Right, what do you think I'll be nasty to if you didn't say nice things? Hete, all this stuff, I mean, Paul's definition, Catherine's definition, it was all about staying at a level. To what extent should we be investing in reserve strength for resilience, do you think?
We should. To what extent is difficult to say, but I would use 2 or 3 keywords. One is redundancy.
Right.
Second one is robustness, and I'm personally taking it a little bit to the system side. I'm an avionics expert by...
We all have our problems, Hete.
Exactly. And the last one, I think, is agility. And agility
I was really hoping that was going to start with A. I really was. Right. But
yeah.
So robustness, resilience,
and agility.
And agility, right.
I think those are for me, what resilience means. We need the agility, we need the people, we need to empower the people to take decisions when they have to take critical decisions. But before that, I think we need to work on robustness of our architecture, robustness of our security, fences around our architecture, around our infrastructure, and redundancy. We still rely, fortunately in aviation, on a lot of redundancy, which makes that, some of these events that we're seeing, we can cope with, our pilots can cope with, they're trained to cope with it, and we should continue to have that.
So redundancy, that is that drives towards what I was asking about, having 110% of the capacity you need, something like that. Mm-hmm. Right.
Okay, but if I may, redundancy can also work the other way around.
In what way?
We have in Europe a lot of redundancy when it comes to the number of radars on the ground.
We do.
They are interrogating like mad the transponders of the avionics, way beyond what these things are supposed to be handling. What then happens is that no information is sent down from the avionics, or wrong information is down, ending up with all sorts of situations in the air traffic control screens, etc. So we need to really balance that redundancy cleverly with our resilience needs.
And the redundancy in that case is driven, am I right, by sovereignty issues, national sovereignty. Each national ANSP feels the overwhelming need to have a 150% coverage of radars and all those things.
Absolutely.
That's not the case in France, though, is it, Catherine? Have you taken Paul's comments on board? Sorry. Catherine told me last night, incidentally, she struggled with my accent, but when Florian spoke English with a French accent, with his French accent, she understood it perfectly. So let me ask the question this way. Sorry, that sounded German too. Anyway, I don't know what happened then. Sorry about that. I can't remember my question now. What are the ANSPs doing to minimise the super redundancy of radars?
Yeah, I think we have a procedure in order. First, we always have several radar, and then depending on the number of radar, we can determine the separation we need to put between the aircraft. So if we miss one radar, for example, we will enlarge the separation between the aircraft because the positioning is less accurate.
So no radars, no flying, is that what you're saying?
No, at least we could manage one flight.
Oh, there you go.
It's the extreme, of course. But you know, of course, we will be able to manage less flight if we don't have any radar. But we still know, and it's interesting because yesterday people were saying we have different generations of air traffic controllers.
Indeed.
And some of them, they remember when they were able to do what we call procedure separation. So you know where an aircraft is, and because you have the reporting from the board, and with that you will take some margin, but you are still able to manage the traffic. Of course, the capacity is going to be really, really low. But still we are able, and I think this is something important also, each time we have an aircraft taking off, we need to be sure, and this is not an option, that we will be able to land it. And no, this is very important because takeoff is optional, landing is mandatory.
Landing is mandatory, absolutely.
And my feeling is that because we have all this robustness, all this resilience, each time we have an aircraft taking off, we know we will be able to land it.
But I still have a massive problem with that. I mean, after the first session, from then on, all we've heard about is fabulous technology, really beautiful technology, glorious technology. We've got all these future systems, and yet, basically, you're telling me we rely on a technology that was invented during World War I.
No.
Is that right?
No, your question was, if you have failure, and why is the system robust? It is robust because at the end, if we have unpredictable events such as malicious act or failure, we don't know why, or power supply failure, we know we still have the basic procedure to be sure that we will manage safely all the traffic and we will be able to land all the aircraft.
So this brings us back, though, doesn't it? This brings us back, though, Catherine, doesn't it, to Jesper's aim of simplifying stuff. What you've basically said is what we have to do is keep the really old-fashioned, really classical fly-by-the-seat-of-your-pants technology. And I'm put in mind, I drive a manual motor car, a stick-shift motor car. And apparently now in Australia, for what it's worth, I don't drive it in Australia, my insurance premiums will go down because nobody knows how to drive a manual motor car anymore, so they don't get stolen. And they don't get on-sold, right? And that's what you're basically saying. We're going to use the stick-shift manual radar system forever. Where are the guys talking about simplification? Isn't this the sort of streamlining that? Isn't this amazing, Dan?
Yeah, because you know, technology helps us to be more and more efficient, and we have AI helping us do stuff. And as we get more and more advanced, we unlearn some of the basic skills. That's the real
classic flying.
Yeah, that's the real danger to the digitalization that's happening. But we can't not use the technological advances that we're seeing, because we need to do that to make flying possible for as many people as we can, obviously. But then we need those procedures. We need to train them so we are able to.
So we need to train. We need to train the controllers and the pilots to still fly the aeroplane.
Yeah, that's part of the operational cost of having a setup. That we need to train that all the time. Scenario training. What do we do when the technology disappears?
So at one level, and I am labouring the point, but I'm not trying to labour the point. In terms of our theme today for the future is going to look a lot like the past in this regard. At least
we need to be able to remember the past at least.
Okay.
So we need to be able to. Today nobody can sew a pair of pants, right? In the 70s, everybody sewed their own clothes because that's what we did. Now we can produce clothes really easily and cheap in the East, and nobody does that anymore.
And those who forget the past are destined to repeat it, of course.
Exactly.
Yeah,
exactly.
And of course, it's a backup procedure. So and it's the same on board. Every day we are using GNSS procedure. But if we have a failure on that...
Thank you for raising GNSS.
And we know how to navigate with the old-fashioned, with VOR.
With an astrolabe.
This morning, the pilot mentioned NDB. We still know how to do those procedures, and each year we are tested to be able to use this procedure. So
to get the astrolabe out, to look at the sun, to look at the stars. I think it's marvellous. GNSS does make me think of spoofing, however. Is this a problem, Hete, at the moment?
It absolutely is.
Is it a growing problem?
It absolutely is.
Great.
It's interesting to mention. I was having a discussion with a colleague from one of our major OEMs the other day, and he was saying, well, we put trust on GPS, and we should still put trust on GPS because 80% of the world is not affected. And then one of my colleagues stepped in and he said, yes, but 80% of the flights in Europe is affected by jamming and spoofing. And
80%
it's increasing.
80% of the world doesn't, excuse me, doesn't have a lot of aviation. That must make your life at Eurocontrol a bit hard, Paul, doesn't it?
Absolutely. We have actually, as part again of our network management responsibilities, a network of about 80 antennas out there in the whole of Europe, whereby we are monitoring in real time what the GNSS health, so to say, is. And whereas up to 22, we saw it happening, occasional. For example, when the police was trying to protect money transport, they thought it would be a good idea to jam some frequencies so the bad guys wouldn't know where the trucks are, and then accidentally they would also jam the GNSS signals, etc.
So a note to any thieves out there: if the GNSS gets jammed, there's a money truck driving around.
Yeah.
Just
that is what we saw.
Yeah.
I would say up to 22. Then in February 22, with the invasion of Ukraine, things changed drastically, and certainly in the Baltic area, around the whole eastern frontier, etc., we saw a dramatic increase in jamming. And then also in 22, 23, I remember vividly talking with many of you at that time, spoofing was something that we heard about from the science fiction, from some labs. Somebody knew of a clever student who maybe was able to jam something somewhere. All of a sudden now in Europe, it's happening every day.
So let's ban universities, I reckon. So what's the difference between jamming and spoofing?
So jamming is when the signal gets corrupted, and you don't have it anymore. Spoofing is when deliberately they give you a different lat-long position.
Right. So
that's scary stuff, because you do not always realize that spoofing is happening, and so you think you are somewhere and you are somewhere else.
Right, right. And is this specific to GPS? My question actually is, why don't we do more about Galileo? Is Galileo the solution to this?
I think we absolutely need to go for a more robust European system, and Galileo, I think, is fully part of it.
Absolutely.
Yeah.
But it's the system we've got.
Yeah, when it comes to jamming and stuff like that, the real problem is the distance, right? You have the satellite up here, and you have the transponder down here, and then it's easy from a distance far away to block that signal. So if those two objects are closer to each other, it's way harder to block it and to jam it. So that's why it's not only a GPS, Galileo, whatever problem. It's a satellite through transponder or receiver.
So is it safer if we use low orbit satellites or extraordinarily tall transponders?
I think that's why I think like ILS, it's not going to go away because it's so much closer to the airplane. So
and comes back to the robustness and resilience.
Exactly.
Point.
Yeah. So it's old-fashioned, but it's still very robust.
Yeah. It may be good to make a clear distinction. In terms of jamming, pure jamming, I don't think there is much benefit that we'll receive from Galileo. In terms of spoofing, because of the authentication service that Galileo offers, that makes a huge difference. Unfortunately, however, we're not there yet in terms of standards, in terms of certification. It will take some time. So time is our real enemy here. We have the technology, but it's getting it implemented in the aircraft.
And getting the rules written. If only there was an organisation that wrote aviation safety rules.
In this case, I don't think it's the rules actually.
Right.
We can do it. It's really we need to have industry agree on the standards, and we can apply those standards as soon as they're available.
Do we then run the risk? If we have Galileo and we have GPS, and of course we still have radar and VHF radio, another World War I technology, by the way, VHF radio, that the aircraft is now getting more and more stuff on board. Shouldn't we be aiming at streamlining and reducing the cost and reducing the complexity for the pilots up there?
I think perhaps I will start and you will complete my answer. I think now for the pilots, the HMA is really, really friendly. So when everything is working, it's quite easy to understand. Perhaps the difficulty is because you have the autopilot, you have a lot of automation on board, is to come back in the loop of decision as soon as you have a failure. And it's very difficult, and it's a little bit the same for ATM, and it's what kind of information do you need to be able to have a good situational awareness of what is happening, so that you could take, so it's a human decision to say, okay, it's an abnormal situation, or perhaps it's an emergency situation, this is what I should do. And probably it's also the same for malicious acts, because you cannot predict unpredictable attacks, for example. So you need to give to the human the information he's able to understand and which will help him to act.
Or her.
Or her, of course, in the good direction. And this is difficult.
Where you're going, Catherine, no, I mean, all this is terrific and fantastic, but we're basically asking, we're not getting rid of things, we're layering in further layers of complexity into a job. I mean, I realise being a pilot's not all that complicated, let's face it, but you've got to water coffee. I mean, it's not completely easy, but, and anyone who doubts that, incidentally, I can't recommend to you enough going and Googling Qantas pilot bus driver. During the pandemic, the head pilot of the Qantas A380 fleet needed a job, got a job as a bus driver in Sydney, was driving around in Sydney and had to, interface with the passengers and all those things. Already for a start, that's a thing a pilots hate. But he only had 40 passengers, not 400 passengers, which justified why he only got 1/10 of the salary. And he didn't get a fancy hat. But he said, this is so hard, this job. You have to pay attention all the time, right? So I have precisely zero sympathy for the pilots on this matter, but you have made it that they do have to pay attention all the time now. Suddenly they have to learn cascading numbers of systems. But sorry, Paul, I'm still trying to come back to the malicious part. Jamming and spoofing is by definition malicious, right?
Yes. Sometimes it's accidental.
Yeah.
Those ones were quite easily to pick up. Then when we see the location where it's happening, we know, that's them, we give them a phone call. But the majority of what we see is malicious.
So the big majority is malicious. Are we able to say who?
I always say it's both the good guys and the bad guys.
Right.
It's happening everywhere. If you take, for example, the southeastern Mediterranean area, I mean, I wouldn't put my finger on only one party. It's several parties.
Right, okay. And you mentioned earlier the Baltic area, and of course I always think of Brussels as perhaps the prime part of the Baltic. It's clearly there. I mean, Brussels and indeed Copenhagen have had all sorts of problems in the last little while. Are they...
Yeah, because you're referring now to the increasing complexity on board with systems, etc. But life is also just getting more complex. Yeah, 7-8 years ago, we really woke up for the cybersecurity threat. And we all had to put in place all sorts of defense mechanisms, and even today, continuously need to do better and better on cyber security. Yeah. Then, what is it now, 3-4 years ago, we started on the GNSS RFI, and since a couple of months, we now have the drone issue around a couple of airports. We've seen it in Brussels, in Copenhagen, etc. Yeah. I think change, also the bad change, is permanent. And we just need to live with it.
So that's good news, yeah. Just, you mentioned cybersecurity as well, Het, and Paul just did. Is the solution to put an incredibly hard shell around stuff? I mean, don't you run the risk if the shell is penetrated, then all of a sudden everything's exposed?
I don't believe in that. I mean, I think certainly in ATM, air traffic management, where I come from, we've been really good in building what I always call the pyramids. Things that take decades to build.
Yep.
Yeah? And then when you want to make a change, you basically have to build a new pyramid.
Yeah.
What we're not so good in is much how the Bedouins are traveling through the desert, put up their tent, break it down next morning, be very flexible, etc. That's something that we're still having to learn in ATM, to be much more resilient, much more flexible in changing one system, one module here, there, etc.
Okay.
And that is just where we need to go.
But bring it back, if I can, to cyber threats and hard shells. What's your view on that, Hedvig?
We need those hard shells, but we shouldn't be naive thinking that once we've built this castle, everything is safe. I think what we also need to make sure is that when that hard shell is penetrated, it doesn't cascade into too many other systems.
That sounds easy to say, but I imagine it's quite hard to do.
It's not the easiest thing to do, and maybe Dan can explain more about it because
it's
you
super
apply it
complex, and it's a trade-off, right? That we can do the hardening thing where you only get the restricted access into the system, and you can't go anywhere else from that. But then you have the very complex infrastructure of the network that builds up, and then when there's a mistake somewhere, it's hard to find where's the mistake. So the more robustness you build into the system, well, you get weaker in another spot. So it's a conundrum that you have to think about, right? We need the hard shell, but we need the robustness. We want to know the service is not touched by any changes, so let's not change anything. But we need to patch up our systems and to get rid of the vulnerabilities in the systems as well. So I feel the industry is really slow to get into the new world of we need to patch up the systems way quicker, and we need to be able to address the vulnerabilities in the systems.
Why do you think that's the case?
It's because we're scared of when we patch the systems, we change something in them, and sometimes when you change stuff, you don't always get the change you want. You get bad change as well.
Yeah,
so that's
unintended
why
consequences.
Exactly. So that's why we're like, okay, let's not change anything, but. You don't get
How's that working out for you?
And even if you doesn't change anything, it's very difficult, almost impossible, not to be connected today.
Well,
so
indeed.
As soon as you are connected, I mean, you have this cyber risk, and you need to apply security rules. And I totally agree. It's a balance. You have to find a compromise, saying, okay, I need to update my system. If I don't use the network, it will take months to do that. So I need to be connected.
And not just on that area. I mean, we need power. We need, telecoms, of course. We need the inter-Google. All those things we need.
Again, I think if we take the other example, again, without any finger pointing, but 2 months ago, we had the stranding of a lot of passengers in Brussels, in Berlin, in Heathrow, etc., because in terms of cybersecurity, we hadn't been properly or good enough managing our supply chain. Yeah? It was again a wake-up call that we're in an interconnected world where everything depends on everything, etc. And even if you subcontract, it doesn't mean that you remove your responsibility to still do things properly. And for once, I'm a big fan there of regulation. The Part IS, I think, says exactly the right things on what to put in place in terms of supply chain management. So the tools are out there. We just now need to pick them up and pragmatically implement them.
Okay, again, that sort of interface into the future. How do we build future robustness and resilience, which is the question du jour? And the answer seems to be by having everything.
Well, no, we don't need to have everything. But I think what we've historically done in aviation is we've looked inwards. We've looked at our own systems, at our own procedures, at our own people, and thought what could go wrong. I think what we haven't done well enough is to look to the environment in which we operate. And it's changing rapidly. It's changing by the day. You asked us 2 years ago, would drones ever be an issue like it's been in the past couple of months? And we would have said you were crazy. Today, it's a reality. We really need to, change the way that we do our safety and security assessments, and think about what is the worst scenario that we can think of that could happen in the environment, whether it's malicious, whether it's spectrum, whether it's, for example, the use of clouds. If we take the use of clouds into the geopolitical spectrum, most of the cloud providers are US-based. The software that's running those clouds is US-based. And just yesterday, I was reading a newspaper in the Netherlands. The cloud system that is used by the government for all of us to log into if we want to exchange is being sold to a US company. Is that what we want?
Well,
would be my first question.
Well, indeed, is that what we want? You've raised a number of really interesting questions there. that interdependence that we have, and Paul talked about supply chain management, supply chain auditing, I guess. I always get the feeling that the bad guys know what we're doing, but we never know what the bad guys are doing. I suppose that's to be expected. I mean, and if it's unforeseeable, you can't foresee it, and I hear that. But there are bad guys out there thinking of things that we haven't started to think of yet, right? And they seem to know what we're saying, which only begs one question, I think, which is, how many of you are actually bad guys here on the I mean, and what are we doing? Does EASA send people to meetings of bad guys like this to sort of work out what we're doing next?
No.
Why not?
I don't think, well, maybe we should.
Yeah.
Certainly when it comes to cybersecurity, well, yes and no. I mean, certainly when it comes to cybersecurity, our experts, go to these places where they meet ethical hackers. They understand those processes.
Do they?
And when we do assessments at aircraft level, sometimes they bring in those people to see, can you actually interact? Can you get into the aircraft systems and do something malicious? So that's part of the cyber security certification that we do for the more complex programs.
Yeah, and let's also not forget that cybersecurity, to a large extent, is also a commercial business. It's just that they're not on eBay, selling their business. They're on the dark web. So we are, and without disclosing everything necessarily, we are connected to the dark web, whereby you need to have several language skills in your team to detect in what's happening on the dark web in terms of people offering their services, or what happened to Eurocontrol 2 years ago, where they declared on a Monday morning at 9 o'clock, guys, we're going to attack Eurocontrol at 9:15, please all join in. And we had at that moment 15 minutes to really put up the firewalls and do all sorts of tricks, etc. But again, if you look at the ransomware attacks, it's a commercial business. Look at the DDoS attacks as well. When there's in the Belgium newspapers a story that the Belgian government is maybe thinking of using the Euroclear funds, we know that the DDoS attacks are up immediately because some of the bad guys are paying the hackers to attack us. It's a commercial business. So you need to connect to that shop, so to say, to understand better what the things are.
And that, Your Honour, is the case for the defence.
And we need to be able to explain to the public what are the effects of these attacks, because the DDoS is a perfect example of an attack that's not in any way harmful, or it doesn't do anything. It just blocks you from going onto the web page. They don't get into the systems. They don't get any data. They
just brings you down.
Just brings attention to, okay, you're being attacked, but there's a difference between how you're attacked. And it creates that uncertainty in the society that the malicious people want. And so we need to be very precise when we communicate what is this attack about.
Which brings me perhaps down to the whole point about the drone attacks that Copenhagen, Brussels, other airports have been suffering. Do you have any, I mean, apart from obviously being very disruptive, why are people doing it?
The drone thing, we all saw it in Heathrow, right, in 27. We saw that in Copenhagen as well. Pretty often, actually. We have these, we call them clueless and careless drone pilots flying their drones where they shouldn't fly their drones, and we're able to detect that with the systems we have in place in the airport, and we send police to the drone pilot, and he gets a huge fine. And
you mean Gatwick, actually? I think not Heathrow. But
sorry, Gatwick. Yeah. But somewhere in Britain.
Okay. Yeah.
So that was one like it's over Christmas we see that all the time, and now the we see a change in the
But these recent attacks haven't been careless, clueless.
That's not the same thing at all, right? Without disclosing too much, but that's a whole other pattern of operating the drones and the way they fly and the technology that they're using to fly.
Disclose as much as you can. Yeah. What are the patterns? What's the technology?
The technology is it's bigger drones. You can't just take them down. It's bigger drones, and
why not?
They communicate.
I mean, the bigger they are, the easier they are to shoot, aren't they?
Yeah. First of all, it's not an airport task to shoot down things that's in the air.
Where is your sense of fun? Where is your sense of adventure?
So I think we need other authorities to come in with their guns if they would like to do that. But when it's not a hard thing to shoot down the drones necessarily, but then they tend to hit the ground at some point, and it's hard to realize where they're going to hit the ground and what are they going to hit when they go down. So that's a huge safety concern when you're in an airport environment and you're having these pretty big drones and you're thinking about putting them down. We need to really be sure of that. But no doubt about that, we need to communicate about how to handle these situations.
But one assumes pretty big drones, I mean, apart from the obvious fact that they're easier to see, I mean, they must be easier to detect.
Yeah, they at the situations that we've seen in airports across Europe, they have this same pattern of operating. There are multiple drones coming in from different directions with their lights turned off, and then when they're inside the airport area, they turn on the light and say, "Here we are," to disrupt the operation of the airport, and then they maybe shift a little bit, and then they, at the same time, shut off the light and fly away, and then they come back after 15 minutes from a different direction. So it's very orchestrated the way they operate. It's not just a stupid boy who got a...
Sure, I mean, these are not, this is not a...
No, this is on purpose. We want to disrupt the airport operation.
An accidental man or boy, it'll always be boys, man or boys with, with a Christmas present or something.
And perhaps if I may, it's really not expensive to fly drones. It's easy, not expensive, and the impact is maximum. So I think it's probably malicious people, but perhaps not so malicious. It's before you had the phone alert for a bomb, and you could put a mess in an airport. Today you can just use a drone. It's not expensive. But you will succeed for sure. Probably, it's very difficult to catch the remote pilot because we don't know where is the remote pilot, and it's difficult to detect even if you have some very high technology system which hybridize acoustic camera, thermal camera, lidar,
is that right, though,
radar.
Catherine?
It's expensive.
Is that right? I mean, if the things are being controlled, so there's got to be radio signals, and my understanding is about a squirrel metre deep, but my understanding is that if the only people that currently design and operate drones that have non-detectable radio systems come from Russia. So there's a big hint, right? But at the moment, what happens? Someone flies a €100 drone into an airport and we scramble a €100 million jet, right? I mean, is there... I don't know, proportionality, it doesn't quite sound right. The second thing, sorry, just while I'm... normally with terrorist attacks, and let's for them today describe these as pretty close to terrorist attacks, I mean, obviously disruptive, there's a mad scramble of people all claiming responsibility. The first job the police have got to do is weed through which of these claims for responsibility are real and which ones are fake, and there's all those code words and stuff that they use. But I'm not seeing anybody claiming responsibility for upsetting Copenhagen Airport or Brussels Airport or whatever. I mean, can't we even rely on the bad guys to behave properly anymore? Is that what we're at?
I think it's been I'm not into politics, but I read the newspaper as well as Hedda, and it's about hybrid warfare, right? We want to introduce, it's the same with DDoS or whatever, you want to introduce the uncertainty into society, to take away the trust of the people into their governments, that we're in control of what's happening in the country. So you want to place that uncertainty into the country, and you do that in lots of different ways, and you don't always wave your flag around and say, we did it, because if you don't do it well, then you have even more uncertainty.
Your government looks even more clueless.
Yeah, exactly.
Yeah. But in terms of an industry, how do we respond to this? I mean, is it EASA, is it Eurocontrol's job? Perhaps it isn't. But shouldn't we be building drone shields? I don't know what the right word here would be, but is these attacks, as Catherine says, these attacks, can be funded out of petty cash.
Yeah.
And yet here we are stopping airports for half a day.
Yeah, so definitely we need to have different technologically capacities to be able to detect the drones as early as possible and be aware of where they are and what are the real risks to them, because there's different risks depending on how big they are and where they are. And then we have to have really close collaboration with the authorities and train, like as we always do, like scenario training. What do we do when the drone comes in? Who does what and when? When do we shoot it down? In this area we can shoot it down. In this area we can't shoot it down. Who shoots it down? Probably the military or the police. We need to have those procedures in place.
Or you get a drone shooting down department in the airport. I still think that'd be more
I'm
fun.
not sure.
But Zahed, this comes back to EASA, doesn't it? If we're talking about the future, this is clearly an area that is growing and is very problematic and is absolutely a safety issue for everyone, as well as a commercial issue and all those things. And I mean, are there any technologies to stop GNSS/Galileo spoofing and denials and jamming? Is there any technologies that we can reliably start to speculate on for things like the drone attacks?
Well, the drone attacks, I think, is a more difficult case, and I'm not sure that that's something that we at EASA can resolve.
And it's not just difficult because you've got to use the word conspicuous. I'm a native speaker and I can't do it. I was in awe of the previous presentation.
When it comes to GNSS, however, yes, we are working on technologies. We're working on new antennas that use beamforming, so they can exclude the area where they think that the spoofing comes from. Those pseudo satellites or those signals can be excluded. So that's on its way. That's coming. I think.
So sorry, that's directional GPS.
Right. Yeah. Right. So you know which satellites you can trust.
Right.
And therefore you beam your signal
up and to
more specifically to those satellites, and you ignore the area where you believe the spoofing comes from. That's a technology that's already in use in the military. We now have to make sure that we ensure that we have standards for the civil application of that, and that's in works. The other thing here, I think that's important to note, certainly on the larger airplanes, we have inertial systems, we have radio updates, and I think that we should, as an industry, be more mindful that when you design an architecture, and I'm using one of the more recent aircraft, 40 systems on board of that aircraft are using inputs from GNSS, 40. And I'm asking the question, why are we making ourselves so dependent on a single sensor input? That's what I also mean with having this redundancy. And whether that's a GNSS sensor or whether it's a pitot probe that could freeze up, whether it's a radio altimeter, I think when we look at aircraft designs in particular, we need to make sure that we're not reliant too much on a single sensor, that we use multiple sensors. And that's, in terms of aircraft navigation, something that we really work on. We're also going to work on using an older technology again, not quite World War II, but closely after, DME.
Right.
We have all those DME stations. Why don't we use them in a better way?
Isn't one of the answers to that because we don't have the spectrum, or that they're so spectrum heavy?
I don't think DME is necessary. Well, we have a few issues with spectrum and DME, but it's not as much a problem as we've seen, for example, with 5G and the radio altimeters.
Right. But spectrum is an issue for the aviation industry.
Spectrum is an issue. Spectrum will continue to be an issue for the aviation industry. And at the same time, I think we've always been thinking of spectrum as it needs to be protected. It's safety related. There's a lot of data that we can share these days that doesn't necessarily have to go over those links. So we can be more efficient in how we use spectrum. We could use commercial spectrum for certain elements. We could differentiate between safety, regularity of flight, time criticalness, etc., etc. I think we need more distinction there in the discussions that we're having on spectrum. Where the spectrum that we absolutely need to protect at all times, like ILS, well, we have no alternative. There's other areas where we can be more open to using, commercial, like satellite. Satcom is a good example.
Yeah.
And also the cost. I think the cost, when you have DMEs, VOR, ILS, I mean, the maintenance cost is really high. So there is this temptation, but it's always the problem, this temptation to say, okay, GNSS is low cost, in fact. So it's easy to use, low cost, efficient. So we
Easy
would
to
like,
jam.
and this is really the temptation. And in France, for example, we decided to have a minimal network of old systems like VOR and DB, just to be sure that in case of GNSS failure or attack, we are still able to manage the traffic and for the navigation.
And train the pilots to use a manual giver.
But you know, it's always the backup solution.
Well,
We want to be sure we can manage safely all the aircraft.
Yeah, no, I really want to support Hatton as well in terms of why is the GPS signal wired to so many systems in such a dependent way. What we see as a side effect of the interference at the moment is that the data link communication, the timer gets affected. And then all of a sudden you have flights that can't use data link anymore. And again, that's directly affecting then the much needed capacity that we have. But I also really want to stress that this is not only about technology. I mean, I've heard you asking, what is the magic technical solution?
I don't think that was my exact question.
Well, that's what I heard. Again, I think, first of all, thanks to the great leadership of Florian, Jesper, and all the others, etc., we have just published the first draft of a GNSS RFI action plan. When you look at that action plan, we describe a future where hopefully all of this will disappear, but what we have to do in the short to medium term is much more on the operational side. Make sure that the people are much better trained how to report the issues. How do we properly write a NOTAM to say that there is GNSS interference? How do we make sure that the pilots are properly trained in simulators to deal with RFI, etc.? Do we need to standardize the phraseology, the procedures, etc.? There's a lot of things we can do now immediately to make sure that the unrest that gets created in the cockpits can disappear. And again, we don't need any technology for that. So I just want trying to give the signal. We need to work on technology and on the operational side.
Right, and also in the work that EASA is doing, I mean, I'm trying to think of the right word here, it's not standards, is it? It's procedures, I guess, or whatever, but it's to make sure we have layers of stuff that we're doing. Yeah. Can I just quickly move on to something we started to talk, Catherine mentioned it earlier, we started to talk about things like our power supply. We saw at Heathrow what happens when the substation, someone trips over the wire or hit the wrong switch or whatever happened at Heathrow. But is that another issue for us? I mean, how do we build robustness and resilience in an environment where we have to plug stuff into the wall to get the electricity that we need? I mean, do you have a backup generator at Copenhagen?
Yeah, you do. For sure we do. Yeah, and we have it both like locally with the systems that we operate, and it can go for a period of time, and then we can set up other systems as well. So that's a huge part of the redundancy, and we don't only rely on the public power supply, but we also have the local power supply that we need if the public goes away, and we actually rehearse that as well.
Do you?
So we pull the plug and see does it work, the system, because you need to rehearse that. And we had some surprises when we started doing that. I can tell you that we thought we were in place, but it didn't necessarily work.
Yeah, right. Oh. Well, I can assume, having been in Copenhagen for the last 3 days, it's not based on solar power anyway. That's for sure. But is that something we should be standardising? Should every airport, every ATM tower have a backup generator? Does it already? Do you in France?
Yeah. We have one. After, I mean, it depends how long you need to use it, because you have a limit for sure. And after, you can also decide which equipment, just to save money and to be able to use for a long time this generator. But yes, we have some, of course.
You've got to start shedding load at some point.
Yeah, and we test it regularly just to be sure that
So let me ask everyone a completely stupid question. Where are we going to be attacked next? What's our next vulnerability? Start with you, Hetty.
That's a really good question. And the answer is I don't know. But I do think that we shouldn't be naive. it's going to happen. We don't know where it's going to happen. We don't know when it's going to happen. And I don't want to picture, something really dark. I know Maria last year couldn't sleep of some of the things I said at this conference. But it comes back to, assessing the environment in which we operate, assessing of our vulnerabilities. For example, anything that's spectrum related can be jammed, can be spoofed.
Right.
Yeah. How do we deal with that? How do we make sure that we have that robustness and independence?
How do we deal with that?
I think, again, this comes back to looking at scenarios outside of the aircraft, outside of the ATM system. We were just talking about, power supplies, and you need fuel for that. And one thing I keep in the back of my mind is this Fukushima accident, where they had everything in place, but they never thought that when that big wave of the tsunami came in, it would wipe out the tanks that they needed for the cooling. It's a very simple, it's something that could happen. It's something that someone could have thought of. You could have placed the tanks on the other side of the building, and everything would have been fine. And we need that, common sense in how we approach things. Have people think about what could happen, how can we prevent that, how can we make sure that we're robust, that we're resilient, and that we have that redundancy.
What did Einstein say about common sense? Common sense is a body of prejudice laid down in the mind prior to the age of 19. Might have been 12, prior to the age of 12.
Yeah, it's hard to predict, especially about the future, right? So it's really hard to answer that question.
I know.
Yeah.
I'm the man that asks the questions. You're the people that answer them.
But in my opinion, I think that a thing like information is one of our biggest weaknesses right now. So misinformation, malinformation, you can create with AI perfect, credible images and persons talking, and you don't know that it's not the person you're talking to actually, because you have the video and stuff in front of you. So that's a real dangerous. Can we trust the information that we're giving? In the current state. So when Nana or Lars is calling me from the civil CAA, and it's not actually Lars telling me to do something, it's a Russian guy.
Yeah. As you said before, I mean, part of what people are trying to do is break down trust.
Yeah.
Yeah. And aviation really depends on trust, doesn't it? You just got to trust this airplane will get there safely.
So that's really dangerous for us, and we need to figure out how do we validate the information that we're giving. That's so important for us.
So we need to start work. Validation procedures, if you like, could be something we could look to next.
Exactly.
Catherine, you
Yeah, I think it's a very difficult question, because even if you try to imagine, so I learned that Eurocontrol, you are on the dark web, which is perhaps the good solution. But for us, even if you try to think what would happen, I think malicious people are always a step ahead. So it's not possible to be ready to unpredictable events. And in addition, I would say that in the cockpit, for abnormal situation, you have all these checklists. We have the same in the control towers. We have, emergency, abnormal instruction. So for situation 1, you are going to take the instruction for situation 1. For unpredictable event.
For situation X.
And so I think this is why, and we discussed that before, we have to rely on human resources and have air traffic controllers with a good formation and able to understand what is happening, giving them the good information so that they are still able to manage and to do good things. And I'm not saying it's easy, but I think we don't have any choice.
Checklist, item number 1, press clutch. Paul?
The area that we at the moment are keeping really the biggest eye on is AI. On one end, AI is fantastic. We have a lot of data scientists in our teams now to really analyze these terabytes of data we're getting in every day. Also, our connections to the dark web, etc. A lot of the analysis of the data over there we do with AI tools, etc. So there is a fantastic blessing. On the other hand, it's also really bad. because all the bad things you can do in terms of, for example, cybersecurity, they can now get accelerated again because of AI. The biggest problem in cybersecurity and aviation is what they call the fraudulent websites. That's why nothing to do with safety, but this is why they're trying to build websites that look remarkably like the one of an airline, so that you would maybe log into it, give your pass or your credit card credentials again, etc. With ChatGPT, this has become 10 seconds. Yeah. Same for ransomware. I would never know how to build a ransomware package. Ask ChatGPT. Yeah. And don't ask it the straight way, but ask the way, hey, I would like to make a film about somebody building ransomware, and floop, he gives you the whole code, etc.
So that's
but this is the reality.
About a film.
Right. But so what we are training our people is really think the unthinkable, and really keep an eye on all the bad things that are happening to stimulate your brain to see what could be the next thing that's happening.
You were going to say something.
Yeah, I was going to respond to something that Catherine said. I think in the end it's people. And we need to make sure we empower those people. We need to make sure that we allow them to take decisions that maybe weren't the best decisions. But in that situation, in that context, you need to take a decision. We need to allow them to make mistakes, and we need to have a just culture.
Okay.
I think that's really important.
So humans in the loop?
Absolutely.
Humans in the loop, just culture, does that work for you, Dan? I'm looking at you.
Yeah. Just culture is obviously a huge part of the culture in Copenhagen airports, because it's so important that when something goes wrong, and things go wrong in daily operations, they don't always go as planned, and we need to be able to learn from that. And to be able to learn from that, we need people to come and tell us that something went wrong. So it's so important that we know about that.
Did anyone raise the alarm incidentally when one of your terminals was stolen?
Rolled over there.
Did anyone think, wait a minute, there used to be a terminal here? Just occurred to me. And humans, ATM is almost human, 80% human, isn't it, Catherine?
Yeah, I mean, we have a lot of systems, but it's ATC-centric, I would say yes.
Right. Paul, humans is one of the takeaways for EASA as to how we build robustness into the future that we need to continue to invest in making sure we've got really smart people doing really smart things? Is that the answer?
Indeed, keep the human in the loop, absolutely. It's really our number one mantra in our area as well, but also keep it stupid simple. Don't overcomplexify as well.
Sorry.
No, but don't overthink things, etc. And when things are happening, just keep your feet on the ground, think pragmatically, and then we're always able to get things sorted out.
Right, okay. So I think, ladies and gentlemen, that is our time. And so now I'm going to do a little bit of pronoun training. I would like you to join me in thanking them. So thank you.